So now we're going to take a look at what happens when our data doesn't fall perfectly on our standard deviation lines. And if we're talking about 80%, and how do I shift things around and figure out where does a 72% fall if that's not an exact standard deviation. We are still going to look at our mean. Our mean, however, is now going to represent the number 0. So we are going to have to convert all of our values so that the mean is 0. And now, this one standard deviation away is going to become 1. That's that, you can think of it kind of as a distance. So from 0 to 1 standard deviation away, we're going to figure out how does this 1 change our value around. And then this is going to be -1. So what we have to do is we have to convert our numbers into what are called standard normal, or z-scores. So a standard normal distribution is what we're taking a look at. And this is when we have a normal distribution with a mean of 0. So we still have that bell curve. And now our standard deviation, that distance away, I guess if you want to think about it, is 1. So it's 1 unit away is 1 standard deviation away, which of course we know is 34% above and then 34% below. So the formula that we are going to use to transform all of these x values, whatever they happen to be. So we did the cholesterol levels. So we looked at that as being 170 was the mean or something along those lines. We have to make that value so that 170 now becomes a 0. And in order to do that conversion, we are going to use the following formula. That z-score, that z-value, is the x value minus the mean divided by the standard deviation. So you need to know what my mean is, what a physical standard deviation is, and then take that x value and subtract it. So what this will tell us is our z-score. Then what we'll be able to do is we'll be able to look at our chart. As I started pointing out on the last one, when z equals 0, that's my mean. And then z is 1, it's 1 standard deviation above, and we know each of those percentages. But what happens when it's 0.86? Where does that fall? What percent am I at? We're going to have to use a table that will help with this information. So the z-value for particular x value is called that z-score for each specific x value. And it's the number of standard deviations away you are. So if your z-score is 2.1, you fall right about here. And then you can tell, okay, I'm higher than this number of people. Okay. So it's going to give you a specific percent once we start looking at our table, because it will give us those approximations. Or a calculator will give us even more exact values. And that'll be the last part of what we're going to look at with standard distributions or normal distributions, is what is that exact value, as exact as we can get. So first we have to practice just converting this into z-scores so we can figure out exactly where these pieces fall. So this is going to be a nice case. So we're going to take a look at heights. So a survey of a group of women found that the height of a woman is normally distributed with a mean height of 64.5 inches and a standard deviation is 2.5 inches. Find the probability that a woman is at most 58 inches tall. My recommendation to begin with is draw yourself a picture. As clear of a picture as you can. Just like we did before. My mean is 64.5. Standard deviation is 2.5 inches. So 2.5, so 1 standard deviation, and I'm looking at 58, so I'm going to go down. So 1 standard deviation below is 62. 2 standard deviations below is 59.5, and then I'll go 1 more yet, which is 57. So I want to figure out what the probability is that a woman is at most 58 inches tall. So 58 inches falls, let's say, about here. And she's at most that tall. So she's 58 inches or less. So I know that this is my 50% mark. So then this goes between here is 34%. So now I'm left with 16% from here down. So I keep kind of breaking it down. So I can figure out, okay, so this is between 2 and 3 standard deviations below the mean. So I can tell approximately what it is. I mean, because I know at 2 standard deviations below the mean, so from here down, there's 2.5% that fall from here down, so it's less than 2.5%. And I know from here down it's 0.15%. So I kind of have a rough idea of about percentages, but that's not very close. So I need to find out specifically. It's somewhere, it's greater than 0.15, but it's less than 2.5%. That's a pretty big gap. So what I'm going to do is I'm going to calculate my z-score. So my z-score is the x value minus the mean, and then it's divided by the standard deviation. And all that stuff is given to us in the problem. So my x value that I'm looking at is 58, and then I have to subtract the mean, which is 64.5, and then I divide it by my standard deviation, which is 2.5. So when all is said and done and I calculate my z-score, I get negative 2.6. So I know I'm falling closer to 3 standard deviations away than I am 2 standard deviations. Not a lot, but enough. And there's a curve, so I can't just kind of average them, or I can't take a percentage amongst it, because it's not a straight line. It does have this nice little curve feature. So what I have to do is I have to give you a normal distribution table. So please grab a normal distribution table and take a look at each of these, and I'll go through them. Here is our example of our normal distribution table. There's all different types of normal distribution tables. Some of them go by more decimals. The z-scores go by more decimals, so that's part of the nice thing with different tables. This one, just our z-scores are going to have tenths. So when I take a look at my normal distributions, these standard scores are my z-scores. So each of these are my z-scores. And in the problem we just did, we looked at negative 2.6. So negative 2.6 corresponds to my percent. Now, it's important that you understand how to read your table. Most tables will give you a key above it, but it gives me from that value down. That's hard to see on the black. So it's from this table on down, from that spot down. So it will tell me from that z-score down towards the end in the negative direction. So 0.47% is what my answer to this problem is. So from here down, my probability of falling there is 0.47%. So 0.47% of my population falls equal to or below 58 inches. 58 did not fall in an exact standard deviation. Therefore, I had to convert it into a z-score. Once I have a z-score, I can take a look at my table, and my table will tell me the percent of folks that fall from that value down. Next one. Find the probability that a woman is at most 70 inches tall, giving the mean is 74 or 64.5, and the standard deviation is 2.5. So, go ahead, draw this picture out, and figure out what your z-score is. So if I tried to add 2.5 to the 64.5, I do not hit exactly 70, which means I have to convert it. So if I did, then I could just go through my memorized percentages. Not that they're as exact. The table is going to give me more of an exact value. So if I take my z-score, or to find my z-score, I take the value I'm looking at, I subtract my mean, and I divide by my standard deviation. When all is said and done, I get 2.2. And again, that reiterates, if it was exactly 2, then it would be 2 standard deviations above my mean, and I know what that probability is from the last one. So now I go to my table. I look for 2.2. Here's 2.2. 98.61 is what falls from here down. So this probability is 98.61%. And part of the reason I have you draw your table is that way you know if you were going from that value up. Because maybe I wanted to know what the probability was that a woman is at least 70 inches tall. So from 70 up, then I'd have to subtract that from 100% to figure out what the complement to it is. So make sure you read them very closely, and that's part of the reason, again, I make those the pictures, so at least that way you can see it as easy as possible. Now the next case, we're going to look at a range of values. I want to find the probability that your score in English is between 86% and 95%, given the mean is 90 and the standard deviation is 3. So now I'm not saying, oh, I want at least this or I want at most this. Now it's I want from here to here exactly. So draw yourself a picture. Mean is 90. I want from 86 up to 95. So I want this whole probability. So in order to do that, I'm going to have to find my z-scores. Keeping in mind that z-scores start at a value and go down. And start at a value and go down. So now, I'm not just taking a look at my table and getting the values. I have to physically do something to them. Well, let's first take a look at what each of those individual probabilities are. So let's convert each of these to z-scores. So let's start with 95. So 95 minus my mean divided by my standard deviation is 1.7. And then for my 86 minus my mean divided by my standard deviation gives me negative 1.3. So now I have to go to my table and look at 1.7 and negative 1.3. So 1.7 is 95.54, and negative 1.3 is 9.68. From there down for each of them. So let's go back to our problem. So what this first one did is the 1.7 was 95.54%. That found from here down. When I did the 86, that was a negative 1.3, and that gave me 9.68%. So that gave me from here down. However, I do not want either of those. What I want is I want the part that is in between. I want this portion here. So in order to find that portion there, what do I have to do with those two numbers? Subtract them. And I get 85.86%. I had to subtract the overlapping piece because that's the part that I completely don't want in my problem because that gives me values that are below 86%. I don't want the 86% values. So this 9.68 was that from 86% down. So I had to subtract that percent out of there to see what my total percent was that was left. So, based on everything that we've done, you should be able to now answer these three questions. So I'm giving you your mean, I'm giving you your standard deviation. I want you to find the probability that a person scored at least an 80% on the test, so draw your picture. I want at least an 80%, so I want from 80% up. B, I want to find the probability that someone scored between a 70 and 90%. Mark your 70, mark your 90, find those z-scores, do what's needed. And then part C, what score would you have needed to be in the top 10%? If you're in the top 10%, that means 90% of the people are worse than you. And I'll help you out with part C if you need to. But look at that table and think about what your table gives you. Okay, so pause it for a minute. Do A, B, try C as much as possible, and I will walk you through C. So for part A, I found from an 80% down, and then I subtract that from 100%. So that gave me the 30.85%. In part B, very similar to the last problem, I just found each of them individually and subtracted them. In part C, if I wanted to be in the top 10%, that's at the 90 percentile. So now I have to go to my table, and instead of looking at my z-score, I have to find my z-score. So 90%, when I look at my table, 90% falls between these two values. So we are going to pick the value that's the closest to 90%, and the value that's the closest to the 90%, it's 1.3. So now that's my z-score. So now I physically know my z-score. So 1.3 equals that value I'm looking for minus my mean divided by my standard deviation, multiply both sides by 13.4, add the 73.9, and x equals a 91.32. So that would be the score I would need on my test to fall in the top 10%. So based on this information now, you can find any values along the way. You're not strictly stuck to finding those exact standard deviations away. But you got to be able to convert into your z-scores in order to do that.